Hello, Algebra 2, a quick review before our final on Unit 3, Topic 1. We start with number 1. This is review number 1, a circle on the coordinate plane. It gives the equation of a circle and says r squared is equal to 100. If we're doing the radius, the square root of 100 is 10. The angle in standard position means it starts at the positive side of the x-axis and rotates to the third quadrant where there is -8, -6. If you look at my picture on the right, I have shown both the initial ray, the rotation, and the terminal ray. What is the value of sine as a ratio, no decimals? I have both a y value, which is -6, and a radius, which is 10. So I can do a sine ratio of y over r, which is -6 over 10, which reduces to -3 over 5. If I'm doing the measure of angle theta, that is the rotational angle. But first I need the reference angle. The reference angle comes from one of our inverses. I've done inverse tan, so I could get a positive angle. We all know that reference angles are always positive and acute, meaning less than 90 degrees. When I get the answer of 36.9 degrees, that gets added to 180 because in quadrant 3, in order to get the rotational angle, it's 180 plus the reference angle. In question 2, I've got another equation of a circle. I need to plot the point in each problem, in this case -10, -3, and I need to do all the ratios. In order to do the ratios, I have an x and y value, -10x, -3y, and I need my r value, which I solve for here. Make sure you put parentheses around the negatives. When I look at what -10 squared plus -3 squared is, it's 108. 108 is not a easy square root. So you can use either square root of 109 or in your calculator the square root of 109, which is approximately 10.44, and then do your ratio. Sine y over r, which is -3 over square root of 109. You do cosine x over r, -10 over square root of 109, tan y over x, which is -3 over -10. Negative divided by negative is positive. Next page, B. The next point is 4, -5 in quadrant 4. When I do my radius, I get the square root of 41 because 41 is not square rootable. I need 3 more ratios. Y over r is -5 over square root of 41. Cosine is x over r, 4 over square root of 41. Tan is y over x, -5 over 4. In C, it's 2, 7 in quadrant 1. The radius, using the Pythagorean theorem, is square root of 53. It's not an easy square root, so when I do my ratios, y over r for sine, 7 over square root of 53 for cosine, x over r, 2 over square root of 53, tan y over x, 7 over 2. Notice that I am starting always at the initial ray. I am rotating to the terminal ray, which always starts here at the origin and goes to the point that I'm given. Last problem on this page is -1/8. That's going to be in quadrant 2, starting with the radius, which is going to be square root of 65. Again, a negative in parentheses before squaring. Square root of 65 is not an easy square root. Y over r for sine is 8 over square root of 65. Cosine x over r, -1 over square root of 65. Tan y over x, 8 over -1. Next page. Complete the statements. This is the one where I have to give all of the angles in all 4 quadrants that give either the same sign, or if I put a negative in front of the sign, it gives me the same decimal in my calculator. Now, you can do this with bow ties. I can do it right here. And I can say, here's 25. So if I reflect over y, this reference angle is 25, and this rotational angle is 155. So that's one way to do it, because I've got points at the same place. I'm trying to get my cursor back. Oops, still didn't get it. There we go. So 155. If I continue with my bow ties and go down, this reference angle is 25, so 180 plus 25 is, I believe, 205, and it is. Remember, the negative has to go in the front because you'll get the same ratio as 25 degrees and 155 degrees, but a negative in front will change the sign to be positive, just like the first two. Last quadrant is quadrant 4, 25. In order to get the rotational angle, it'll be 360 minus 25 because it's in reference to the x-axis, the closest place, and 360 minus 25 is 335, again with a negative in front, so that all the ratios are positive and the same number. I can do the same thing with 175. When I start in the second quadrant, I can reflect over to the first quadrant and get 5 as the reference angle, same sign. If I put a negative in the front and then reflect either to quadrant 3 or quadrant 4, with a negative in front, it would be 185 in quadrant 3 and 355 in quadrant 4 with a negative in front. 81 is again in quadrant 1. If it's in quadrant 2, angle or rotational angle with the same sign is 99. When I put a negative in front, it's going to be 81 plus 180, which is 261. The negative in front ensures that these signs all have the same decimal answer in the calculator. If I then reflect over to quadrant 4 with a negative in front and a reference angle of 81, the rotational angle would be 279. Last one, 148 has the same sign as 32 with a negative in front in quadrant 3. 212 with a negative in front in quadrant 4. 328. 4 is the beginning of a word problem. You need to graph here, paying attention to the radius and the center and the number of seconds to do one complete rotation. Remember, it's going to be center plus radius. The trig function is always going to be sine. I'm always going to take the 360 degrees in every circle and divide it by the 24 seconds. And then my variable in the equation is t. If I put it in my calculator, it'll go in y1, and then my t will become an x in the calculator. So this is how I find the height anywhere. Once I adjust my graph after putting the equation in y equals, I hit Z trig and then the window so I can see the curves. I can hit the trace button and then 0 and then enter to get the height at 0 seconds. I can then hit trace in 6 and then enter and get 75, and I keep going. Notice after the 24 seconds of one full rotation, I'm back to 40 feet high again. So then the pattern continues in the same way, from 40 to 75, back to 40, down to 5, and then back to 40 at the center. What transformation happens if we raise the center of the wheel? Well, the midline or the middle, as well as the whole graph, would move up. What transformation happens to the graph if we decrease the size of the wheel? That's decreasing the size of the radius, which decreases the size of the waves. That's called the amplitude. We'll talk about that next packet. What transformation happens if I turn the wheel slower? Well, the waves are going to be stretched out horizontally, so it's going to be less waves in the same amount of space. It takes more seconds for the wheel to turn, so there will be less waves between 0 and 48 seconds. I believe that's the last page. That was indeed the last page. And so that's our video. Remember, the PDF of the same answer key is also in Canvas. Good luck with your summative. See you soon.